All right, let's preview some of the problems from section 9.2. For these, we're simplifying radicals. It's exactly like the lecture videos that you've seen. And I think even this problem was on there, the cube root of negative 16. So remember, odd roots, the negative pops out front. And 16, you're kind of seeing if there's a perfect cube factor of that number. So let's just keep going. We're like looking to simplify. So you're going to write it like a number on the outside, then radical symbol, number on the inside. That's what it's going to look like for all of these problems. This one I think I do want to take a look at with you. So when you're doing a root of a fraction, we can think of those two things separately, the numerator and the denominator. So for this one, got 32x to the 5th in the numerator. So I can write that as the square root of 32x to the 5th on top. And I've got 81y to the 8th on bottom. So square root of 81y to the 8th. So I'm going to think of those two things separately. So let's deal with the top first. These ones are the only ones that I think are going to take you some time. Square root of 32 times square root of x to the 5th. So 32, let's see, I could think of that as 2 times 16. And 16 is a perfect square number. That can pop out. 16 is 4 squared. So this becomes 4 on the outside, root 2 left on the inside. Now let's do x to the 5th. What's the square root of x to the 5th? Well, again, how many groups of 2 are there in x to the 5th? You kind of have like, you got your x to the 4th, which is 2 groups of x squared, and then times x. So this x to the 4th, square root of that will be x squared. And there's a 1x left underneath the radical. So now I know what the numerator is. Numerator will be 4x squared. I'm just going to group those factors together. Square root. And then what's left underneath the radical is 2x. Great, so I can start writing that down. 4x squared root 2x. All right, and let's look at the denominator now. It's like the square root of 81 times the square root of y to the 8th. Square root of 81 is 9. Square root of y to the 8th. How many groups of 2 are there in 8? There's 4, right? So that'll be y to the 4th. Because y to the 4th squared is y to the 8th. Okay, so our denominator here is 9y to the 4th. And that is my answer for Hawks. So again, these problems I think are the only ones that are going to take you a while just because you have to do the whole thing with the numerator and with the denominator. Let's skip around and look at a couple more problems. Okay, here we've got a cube root problem. So you're looking for groups of 3 factors to pull out. A lot of these problems are just like the ones that we did on your other lecture videos. All right, we're looking at square roots and cube roots. See what you can simplify. So we're not looking for a decimal approximation here. What we're looking for is pull out any groups of 3 factors and write, there's going to be like an outside number, cube root, inside number, okay? That is what we're looking for with all of these problems. What can you pull out front? What can you pull out of the radical symbol? Okay, and those are going to be all of your problems. Again, you got these ones that are kind of a pain. Let's talk about this one that I think this will be your most difficult, and I have a trick for you. So the last problem that we did together, it was a fraction, and there was nothing that we could cancel. There's no common factors of 32 and 81. And you got an x to the 5th and a y to the 8th. There's like nothing to cancel. However, with this problem, notice that we actually could cancel some stuff before we even start to simplify it. So if you are able to simplify what's inside the radical first and then deal with the radical later, that's how I would accomplish these. So again, deal with the cube root later. And right now, we can just kind of simplify this fraction. 16 divided by 8, well, that's 2. X to the 8th divided by x to the 3rd, well, there's 5 factors of x left in the numerator. Remember that when you're dividing with exponents, you can just subtract the exponents. Y to the 14th over y to the 6th, well, that'll just be y to the 8th. So this fraction simplifies to the cube root of 2x to the 5th, y to the 8th. Nothing left in your denominator, just 1, so you don't have to write it. Okay, so now we can start seeing what we can pull out. So we think of these things separately again. You got the cube root of 2, you got the cube root of x to the 5th, and you got the cube root of y to the 8th. All right, cube root of 2, can I simplify that? Nope, there's nothing to pull out, so it just stays as is. The cube root of x to the 5th, however, here, maybe I'll just rewrite it, cube root of 2. The cube root of x to the 5th, how many groups of 3 are there in 5? Actually, I didn't say this before, but here is a tip for doing these when you're taking roots with variables to exponents. I keep saying you're looking for how many groups of 3 are there in 5. You can actually just do that division problem. How many groups of 3 are there in 5? 3 goes into 5 once. 1 times 3 is 3. Subtract, you get 2. Remainder, 2. So 1 group of x comes out of the radical, and there are 2 factors of x left inside the radical. So if you want to do the division, that's kind of like a shortcut. All right, cube root of y to the 8th, let's see if it works here too. How many groups of 3 are there in 8 y's? So 3 goes into 8. How many times? 3 goes into 8 twice. 2 times 3 is 6. Subtract, you get remainder 2. So 2 y's come out. So you get a y squared on the outside. And there are 2 y's left underneath the radical. All right, putting this all together, let's group all of our outside terms together. You have an xy squared outside, and then the cube root of 2x squared y squared left inside the radical. Okay? All right, so all of these problems, just take them one factor at a time. If you've got factors being multiplied together underneath the radical symbol, do each one separately. If you've got a fraction, you're trying to take the root of a fraction, do the numerator and the denominator separately after you simplify anything on the inside. All right, good luck on your homework.